Let us continue. Now, what I was saying like the last time, the what I was showing you last time, the pressures there in any compression resistance system, there is these two pressure, high pressure. One is called high pressure side, another is called low pressure side. The high pressure side starts from the outlet of the compressor by the delivery valve B and through the pipe to the condenser and then through the receiver to the throttle valve. The low pressure starts from the from the outlet of the throttle valve and through the pipeline from throttle valve to the evaporator and from the evaporator to the suction line of the compressor. The pipeline carrying high pressure refrigerant is red and pipeline carrying low pressure refrigerant is green itself. So I'm just showing you one thing in this schematic diagram. First of all, at the outlet of the compressor, at the position B, the high pressure side of the refrigerant starts. From here, it is going through the red pointed. It is in gaseous state. First of all, it goes to the high pressure is shown in the compressed pressure gauge itself, which I have already shown in the Excel form. In the red pressure gauge, which is the high pressure compressor, which is the compressor at the out pressure at the outlet of the compressor. Next, high pressure side does here to the compressor in the liquid state and enters into the condenser itself. From the compressor to the condenser, then condenser it converts it rejects heat to the surroundings and convert it to from high pressure gaseous refrigerant to low pressure high pressure liquid refrigerant inside the compressor at the outlet of the condenser itself. And this liquid then pumped through from the pressure created by the pump. It is supposed to flow through from the pump itself to the receiver, and receiver it goes to the expansion valve up to this portion. This is the liquid state. And the expansion valve itself. Just one second. Just repeating it once again. And expansion valve, this high pressure reduces the low pressure at the outlet of the expansion valve, but it remains liquid and refrigerant in liquid state from the exit of the expansion valve is go to the evaporator in the low pressure, and in the evaporator the pressure remains more or less same, but it is evaporated by absorbing the latent heat of evaporation from the chamber itself, and then goes to the then it becomes in a gaseous state, low pressure gaseous state, and goes to come out from the evaporator, goes to the low pressure pressure gauge, which is shown as the green pressure gauge, and this goes to the low pressure inlet of the compressor, where it again compressed and become high pressure, both comes out from the compressor itself. This is more or less the system of the compressor refrigerant system. The system of flow is a compressor refrigerant system itself. Now, next comes the vapor compression refrigerant cycle is based on the circulating fluid media. For example, a refrigerant having special purpose of vaporizing at temperature lower than the ambient and condensing back to the liquid form. So we should have that vaporizing. First property of vaporizing lower than the ambient pressure, because generally the throttle valve reduces to the lower pressure than the atmosphere, and the whole system is totally closed. The lower pressure liquid becomes evaporated, and so the refrigerant has the property of vaporizing at temperatures lower than the ambient temperature and condensing back to the liquid form at slightly higher than ambient temperature, ambient condition. So the freezing point and vaporizing point or evaporating point of both this refrigeration should be really close to the atmosphere itself. Just to the atmosphere pressure that is more or less 1.1 to 1.2 bar itself. And thus the refrigerator operates or boils at temperature lower than the ambient. It extracts or removes heat from the load and lower the temperature, consequently providing cooling. So when it starts boiling, it draws the heat required for boiling from the load itself and lower the temperature consisting of providing cooling. The superheated vapor pressure is now increased to a level by the compressor to reach a saturation pressure so that heat added to the pressure is dissipated and heat rejected to the atmosphere during the operation admission conditions. The superheated vapor pressure now is increased to a level by the compressor to reach a saturation pressure so that heat added to the vapor is dissipated, rejected to the atmosphere during operational ambient conditions. So pressure should be the pressure and the compressor will be such that the heat that is evaporated is heated to the superheat condition, means higher than the boiling point of the evaporator, boiling point of the refrigerant itself, and and thus it becomes fully saturated with this temperature and again, so that this heat again is just higher than the atmospheric pressure. It resists the heat to the vapor itself and rejects the atmosphere. Use operational ambient condition itself. The cooling media is to convert the refrigerant into the liquid and form and recycle again from the refrigeration cycle. Cooling media used to convert the refrigerant to the liquid form and recycle again to form the refrigerant cycle itself. Now, what are the components just I have told you? Evaporator, compressor, a reciprocating device, a condenser, and a throttling valve itself. The working of vapor compression cycle and the function of each above component is given below. So, what is the working of evaporator? The liquid effluent from the condenser at high pressure is fed through a throttling valve to a evaporator at low pressure. So, on resolving the heat to be extracted from the media to be cooled, the liquid refrigerator boils effectively in the evaporator and changes its state from liquid to vapor. The refrigerator gains latent heat from the latent heat to the vaporized at the equalization pressure and further absorbs sensible heat from the media to cool and gets fully vaporized and superheated. So, what refrigerator is doing? It is gets the latent heat from the to vaporize at certain temperature and pressure, and again absorb further sensible heat from the media to react by cooling it again, and then get fully vaporized and superheated. So all the liquid particles of the refrigerator will be fully vaporized in the evaporator itself, and the heat required to draw this from the evaporator will be drawn from the evaporator chamber itself as a latent heat, as it does enable the required cooling of our inside the evaporator itself. Now, evaporators can be different from different applications are according to the desire. Defrosting type evaporator, shell and coil type evaporator, and like this. A defrosting type is the one in which frost is accumulated in the coil, and when the compressor is running and melts when the compressor starts off. During the process, the compressor, the complete evaporator remains at a temperature of about -70 degrees to -60. At this temperature, the host frost forms the surface, but after the compression stop, the coil forms into a temporarily slightly above 0 degree centigrade, and the starch melts before the compression starts again. So what we are doing here, first of all, defrosting type evaporator. What we do, evaporator consists of a temperature, -5 to -7 degrees centigrade. Here, evaporator receives the refrigerant in liquid form and low pressure. Heat vaporizes the liquid refrigerant to totally superheated vapor, heated above, superheated means heated above the boiling point of the refrigerants. Thus, all liquid refrigerant gets vaporized and comes out from the evaporator as superheated vapor, superheated refrigerant vapor. Next, it absorbs all such all heat as latent heat not sensible from the surrounding of the evaporator, coil